Hello everyone, this is Kannan. My final literature project on application of data mining in healthcare. In this term project, I will be reviewing the several data mining techniques related to healthcare and will analyze the pros and cons of each and every technique. On reviewing these papers, I found that data mining techniques have been used to analyze, model, and predict the clinical trials on variety of situations. 6 different scenarios where the data mining techniques are used for clinical data analysis are discussed in this presentation. In this scenario, gene expression data is used for predicting the clinical outcome of a patient. Analyzing the gene data, which is present at the molecular level, is the main theme of this research paper. Gene expression is the process by which information of a gene is used to synthesize a functional gene product. Gene expression data obtained from the samples is used for predicting the cancer in the patient. Gene expression profiling is used to categorize the leukemia patients. Data mining techniques are extensively used to predict the clinical outcome from the existing data. Gene has many features associated with it. Handling multiple features in each gene is the key problem addressed in this paper. Several techniques are used to identify the unique features of gene. First one is centroid-based classification, which is used whereby a new gene is assigned value where its centroid values are close to average centroid values. Profiling gene expression, whereby measuring of the activity of thousands of genes at once to create a global picture of cellular function, is used to classify 18 different classes of cancer like leukemia. Using the right feature selection method is the critical in identifying critical feature of genomic data. My personal review on this paper is use of advanced computation techniques produces more accurate result which can be helpful in predicting critical diseases. In this second scenario, MRI image data is used for finding the presence of Alzheimer's disease in the patients. Several other factors in addition to MRI scan data are taken as an input to finding the diagnosis and predicting the future outcomes. The key problem in performing this experiment is handling high-resolution image data. The size of the image and the number of pixels data to represent the patient potentially has huge information. Basic tree techniques are not efficient in solving this big data presented with precision. Hence, in this paper, fuzzy decision tree is used. In FDT technique, we create sparse, linear, and combination of explanatory variables. Using this technique, dimensionally is reduced and appropriate features inherent in the data are selected. My review for this paper was the above two method can be efficiently handle the data features and process it efficiently. Use of parallel processing algorithm and cloud storage can be efficiently handle processing large amount of data. In third scenario, use of data mining techniques is predicting ICU readmission and mortality rate is examined. Predicting ICU availability and readmission of the patient and mortality rate are the key areas of clinical research in this data. Researching in these areas can possibly give physician a better way of predicting whether or not a given patient should be discharged from the ICU or whether a patient should or should not receive a particular line of treatment. 3 unpredictable attributes like starting attributes, feature selection, and classification algorithm are used to predict the ICU readmission. 3 important parameters for prediction are death after ICU discharge, early readmission, and readmission anytime after ICU discharge. My opinion on this paper is although many algorithms may have used to predict this critical information, having on clarity dataset surveyed by using background information and using external information as such source for predicting is vital. Fourth scenario, predicting real-time data in clinical application using data streams. In this study, historical data of patient has been collected for years. This has been supplied as an input for predictions. What is a data stream? Data streams are never-ending streams of continuous data that needs continual analysis but which can give a real-time result instead of using static data sets. Problem in this paper is processing the high throughput data. Historical data and current data as given as an input to the applied algorithm for prediction. Several traditional methods like decision tree, Bayesian networks, neural networks, and rule-based require complete data are inefficient in processing big data. Hence, very fast decision tree is used in this paper. If we have missing data and inappropriate data, the prediction result will get affected. In fifth paper, we are going to review manifold learning algorithm is used to find lower dimensional structured data from higher dimensional data. Applying popular data mining techniques for high-risk population with cancer and cardiovascular disease is the main theme of this research. This research work is key for further cluster analysis, supporting in providing the physician early disease warning. It has becoming one research key point that is how to mine health and disease essence hidden under the superficies and find disease early warning health clue from massive database. The main problem statement in this paper is use of manifold learning algorithm to analyze the high dimensional medical data coming from the medical database which aims low dimensional structure data, providing the technical support for the risk-free factor discovery and health early warning. The data mining technique used to solve the problem is manifold learning. Isomap algorithm is one nonlinear dimension reduction method for manifold learning. High dimensional data space and low dimensional parameter space have isometric mapping. On reviewing this paper, technique process lots of high level information, enough precision on low level data is not preserved. This is a starting point of the research on finding low level interactions from high dimensional dataset. The final paper deals with data pre-processing and mining technology for clinical data applications. Research is developed on clustering and modeling of mining about clinical data. Through pre-processing the clinical data, the quality of network input data is improved. We should carefully investigate the characteristics of clinical medical data and then apply the special pre-processing methods. Artificial neural networks. The model according to the structure and behavior of human neurons and can be trained to identify the classified complex model is useful in mining clinical data applications. In this massive data, people haven't discovered hidden Hessian relationship beneath superficial phenomena. To provide a scientific basis of decision making for early warning of disease and treatment, to promote the development of medical research has become focus of today's studies. The final aim to establish this project is to constitute database of human health and disease, trying to provide information base for medical early warning and intervention. Data mining techniques used here are pre-processing methods and self-organizing maps. Self-organizing maps analyze high-dimensional data visualization in low-dimensional space, but also can use multiple codebook vectors in high-dimensional space to approach data distribution through orderly method. After careful review of this paper, self-classified input based on real-time data eliminates the need for training dataset. With further development of information processing technology, such as data mining, regarding it as an important research method for medical healthcare. Introducing manifold learning of geoinformation science can provide satisfactory results. From reviewing different papers, we understood different data mining techniques to be used applied on different scenarios. Use of machine learning techniques extensively classifies and predicts the clinical outcomes. From the above analysis, we infer that the data mining concepts are increasingly used in healthcare systems.